Chapter 4 is on solving systems of linear equations, which is going to amount to solving for two unknowns. And so we'll do that if we have two linear equations with two variables, we can solve for both of those unknowns. We have several different techniques. 4.1 is on the graphical method. There'll also be some vocabulary that we want to learn along the way. We're going to start though with an opening example. I like to start with some things sometimes that demonstrate, in this case, a systems type of thinking without necessarily in everyday life thinking of it as algebra. So in this situation, we're saying, suppose that we live in South Elgin and we're going to consider joining a health club. And suppose we look into LA Fitness here, and that LA Fitness has a $75, so you see my little screen capture, so at the time I did this was real. I'm sure things have changed. $75 initiation fee and a monthly fee of about $35. All right, so thinking $35 a month may seem like a lot. You're not sure. $75 up front, you're not crazy about it, but you just decide to look around. So suppose that Fitness 19 is also nearby, a little bit smaller, maybe isn't exactly the same, but it has the same machines that, let's say, you want to use, so that seems just fine with you. So Fitness 19, you're going to, and this is, I'm just going to write in parentheses, this is made up data for Fitness 19. So this one I just made up, okay? So suppose that you talk to a neighbor and they tell you that Fitness 19, or maybe just some other health club, costs $10 a month, but that the initiation or the initial fees are $150. So I'm sure that's way too high. I shouldn't have maybe used the name Fitness 19. I should have probably just used some other generic fitness. All right, so here we are, Fitness 19, $10 a month, and initial fees of $150. Now, in this situation, suppose that you're only planning on joining for the next 6 months. Okay? Maybe you just want it over the winter or something like that. So let's look at how much each of these would cost us if we were only going to join for 6 months only. All right, so let's take a look at what LA Fitness would be. And so LA Fitness, $75 for that initial fee, plus $35. And again, I'm just joining for 6 months. So if you multiply that 35 by the 6 and add the 75, that's going to put you at $285. All right, so now let's suppose we took a look at the other one, and let's maybe not even refer to it as Fitness 19, so I'll just call it F, so some other fitness club. And this one, though, has $150, so twice upfront fee, but it's only $10 a month. So 10 times the the 6 months. So the 60 plus the 150, multiply, add those together. That puts us at 210. So it looks like in this situation, it is this second one that would be the better deal. Now, suppose your situation was just a little bit different, and maybe you were away at college and you were coming home and you had a pretty good fitness routine going, and you were coming home maybe over the holiday break in December, January, that winter break, and you just wanted to join, you were only going to join one of these for 1 month. Okay, so now it's a different situation. And so now suppose we looked at what each of these would cost us just for this 1 month that we're planning on joining here. Okay, so in this situation, 35 plus the one-time fee of the 75, that would be 110. And then for this other fitness club here, this is going to be 160. So in this scenario, the LA Fitness would have been the better deal. So, I mean, this is the kind of thing that we do. We compare maybe two different plans. Maybe it's cell phone plans or, depending on how much data I use, and we compare them. So now what we're going to do is we're going to extend this a little bit. And now we're going to associate a couple of variables, and we're going to write a couple of linear equations here. So let's look at writing first the equation here for LA Fitness. So LA Fitness, look at the green at the top there. It was $75 plus 35 times, and now I was always subbing in some number for X that was the number of months. Let's call it M instead. So let's say times M for however many months. And then that was getting me some sort of total cost for that time frame. And similarly for the other fitness club, I have 150 plus $10 times M, the number of months, whether it was 6 months or 1 month, and that was giving me the total cost for the other club. So in both of these situations, that looks great like it is. I'm going to just reorder and interchange the sides. So I'm going to say C equals 10M plus 150. And for the first one there, I'm going to call that one C equals 35M plus 75. And what I want you, kind of why I did it this way, is I want you to realize we get really too used to always thinking of everything in terms of X and Y. But that happens, so let's just kind of write it in parentheses. We really have something now in that good old slope-intercept form that hopefully we're pretty comfortable with from the last chapter. All right, now let's graph these equations. So as we think about even the numbers that we ran through here, subbing in the number of months, but then look at the output values. We're into hundreds of dollars here. So that affects really how we plan our increments as we're getting ready to graph. So, you might have to spend a little time, sometimes maybe even counting this out to decide what your increments are going to be. So I would maybe count up by increments of 10. So 20, 30, 40, 50. So each one is an increment of 10. So 60, 70, 80, 90, 100. So again, keep in mind, I had to make it big enough, 1, 2, 3, 4, 5, in order to be able to fit things here, costs that are up into the hundreds. So that's why we're counting up by increments of 10. All right, so that's probably enough here. So this is my y-axis, and I'll even kind of say this is the cost, right, in dollars of our memberships. Now, along the x-axis, we could just use increments of 1. Most of what we've subbed in 1 month, 6 months. So increments of 1 would be fine. Just to spread it out a little bit, I think it'll be a little easier, essentially, if I use every other increment as 1. So I suppose each increment's a half. So this just counting by 2s, and then that way it'll just sort of stretch this out a little bit. I think it'll be just a smidge easier for us to graph here. But increments of 1 would have been absolutely fine in this case. All right, so as we kind of get some appropriate increments going on there, and so again, let's on our X or horizontal axis, let me say, this is going to represent our number of months. Okay, now we have 2 different equations we want to graph. So the first one was C equals 35M, plus 75. So C equals, so let me just kind of write that here just so I don't forget. Oop, up at the top. C equals 35M plus 75. I want that to fit on the screen. All right, so the y-intercept is 75, so we could do it that way if we wanted to, kind of use the y equals mx plus b form and then go up 35 and over 1. I'll be honest, starting at 35, or 75, I meant to say, so this was 50, 60, 70, so this is where 75 would be, and then going up 35, so each of these, this is increments of 10, so that would be like 10, 20, 35, and then over 1 would put me right here. So it would be at the ordered pair 1, 110 is where that would be. And that's okay. We could continue to do that. We could go up 10, 20, 35, and over 1. So that would put me at 2, and then like 145. And then we could go up 10, 20, 35 over 1. That would put me at the ordered pair 3, 180. So you could continue to do that. We also could have went back and looked at the pairs we found. At 6, I'm going to be at 285. I could add that one into the mix here. At the ordered pair 6, I would be at 285. But actually, I'm just going to go ahead. I have enough points here. I'm going to go ahead and attempt to do my best job here, drawing this with a ruler. Even my ruler is going to make this off a little bit here, but that looks pretty good. I'm relatively pleased with that. All right, so this is, and there's even my label. So that is going to represent, of course, LA Fitness, right? So this is for the LA Fitness. All right, so what's my other one? My other one was for the other fitness club. So that was I'll write this one. C is equal to, C is equal to 10M plus 150. Okay, and then this is that other fitness. I was calling it Fitness 19. All right, so this one has a y-intercept, y equals mx plus b of 150. And then this one's easier. So we're going up 10 over 1. But remember, when we go over 1, it's really 2 increments because of how we have our increments. So this one's much easier. So up 10 over 1, which kind of feels like going up 1 over 2, honestly, as we're graphing this. So this is our set of some points there. Again, let me try to get a good ruler going on there. Hope that'll do the trick. Yeah, it could have been better. As a matter of fact, let me just pull this back a little bit if I can. Riveting video, isn't it? Watching me try to get a ruler straight. I'm sure that's not on how to make good videos. Sorry. All right, so there we go. So something along those lines there. All right, so now what we're really going through is what this whole section is about. So notice everything that we've been talking about here have been concepts we've already learned. So this is the idea. What this section's really going to be a lot about is going to be the point where the two linear equations are equal. So notice this ordered pair at the point of intersection is 3, 180. And if we interpret that, that's telling us that both of these health clubs cost $180 at 3 months. So a lot of what we're going to talk about is going to be about when two different scenarios are equal to each other. That's really what the solving of systems is going to be a lot about. But I think in everyday life, what happens more is we're kind of interested in what's happening to the left or to the right of that. So if we think about the implications of this, if I was going to join for less than 3 months, LA Fitness was the better deal because it had kind of that smaller upfront fee. But if I was going to join for a longer than 3 months, then that second club, it had a bigger initiation fee, but then it was only $10 a month. So that becomes a better deal in the long term. So this is systems thinking in everyday life that we don't often associate with algebra. But this develops our first technique. It's everything we just did. We graphed each line. We looked for the point of intersection. The last thing that we can always do, I didn't do it up above, but we can plug it back into both equations and verify that it satisfies both equations. So let's just end this video with one more example where we're kind of pulling this together and just really looking at what this algebraic process is going to look like for us, especially, in homework type of situations. So suppose I have y equals x plus 5, and we're starting off with two very nice looking equations in slope-intercept form. Y equals negative x plus 9. All right, so remember, we start always first by plotting your y-intercept. Okay, so that's what we plot first. on the y-axis. And so we're going up 5, making our first point there. And then from there, we're using our slope. In this case, the slope is this implied 1 over 1. And so the second thing that we do is use the slope to go, in this case, up 1 and over 1, up 1 and right 1. All right, so the awesome thing about slope, you can continue to count it out in both directions. This is going to be pretty nice in terms of even just being mindful as I'm graphing without my ruler. I'm just making sure that I'm going up 1 over 1 or down 1 left 1. I'm just going through all of those little boxes on the diagonal there. Okay, so there was the first equation, y equals x plus 5. All right, let's take a look at y equals negative x plus 9. So again, since we're in slope-intercept, the first thing we would do is plot this 9 on our y-axis. That's our b. So there's that point. And then the second thing that we do is we use our slope, which in this case is negative 1 over 1, to go down 1 and to the right 1. So from 9, we go down 1 and right 1, down 1 and right 1. And what just happened there is kind of the perfect thing we want to happen, is we want to be able to hit that point of intersection exactly. And so you might already anticipate, like, well, what if it doesn't? And honestly, that's why we're going to develop other techniques in later sections. But we really want to extend our slope as we're graphing these by hand in such a way that we get to that point of intersection. Now, the most important thing here is to make sure you answer the final question. And that is, sometimes students will graph and never give me the answer. We're solving the system. The system is the point that is common to both equations, and that is the ordered pair 2, 7. So remember, the idea here is that the line in blue is all of the ordered pairs that satisfy the equation where the y-coordinate is equal to the x-coordinate plus 5. So if we plug that in and check, it definitely satisfied the first equation, so we know it's on the first line as we check this. The second equation, the line in green, is the set of all ordered pairs where the y-coordinate is equal to the opposite of the x-coordinate plus 9. Again, if we plug in this ordered pair and we see that it satisfies the equation, we now know it's on the second line. That's how we know for sure that our graphical technique worked. So that's the big picture. That's the idea. In the next video, we're going to come back and look at some vocabulary and then continue to look at some examples.